Here's my cool narration on this awesome animation of how we move muscle. So if we zoom into muscle and really take an in-depth look, you'll find that the skeletal muscle is made up of muscle fiber bundles. And these are basically long cylindrical cells that can contract or relax when they get signals from the nervous system through the neurons to the neuromuscular junction. Now each of these fibers is composed of many little myofibrils. And these are split up into individual units called sarcomeres. And sarcomere is what we're going to look at here. So when you look at an individual sarcomere, they're composed of thick and thin filaments. And this is what makes our muscle look striated. So these filaments slide past each other to shorten the sarcomere unit and shorten the entire muscle fiber. Now the thick one is called myosin, and that's connected to the center of the sarcomere on the M line. The thin one, the thin strand, is called actin, and that's connected to the edge of the sarcomere on the Z line. And these basically slide past each other to shorten the entire sarcomere unit and shorten the muscle, allowing a contraction. But what's really going on here is not really sliding. We've actually got the thick filament here, which is called the myosin, and the actin, and the myosin is actually connecting to the actin at these cross bridges and then pulling the actin towards the myosin, allowing the edge of the sarcomere to be pulled towards the center, making the sarcomere shorter. And this simply repeats connection, pull and release to shorten the entire sarcomere muscle. So what this requires is what's called ATP, which is where we get our energy. And this ATP is hydrolyzed into ADP and organic phosphate. This then triggers the myosin to connect onto the actin at these binding sites. And then what we get is called the power stroke, which is where the myosin pulls the actin, which shortens the entire sarcomere unit, shortening muscle fibers overall. Once that step has been completed, the ADP and phosphate are released, and from that point it allows new ATP to connect on, which promotes either the cycle to be repeated, or it just simply disconnects the myosin, allowing the muscle to relax, depending on the signals that it's being received. So overall, we've got an amazing process going on here at the molecular level at a simple muscle movement. So in summary, we've got the thick myosin filaments pulling the actin filaments, and this is within the sarcomere unit, pulling the edges of the sarcomere towards the middle, which shortens the sarcomere unit and contracts it into basically a smaller size. This contraction of the sarcomere unit will shorten the muscle fibers within the entire muscle belly, making your muscle contract. Then when your ATP runs down, you get tired and fatigued, and your set is done, my friend.